Alright, part 2 here. So we're going to do a little bit more with graphing, have a little bit more interesting things happening. So H represents a horizontal shift. Remember, horizontal goes left and right. So H is going to tell us how far left or how far right. And K represents a vertical shift, which will tell us how far up and down to move the graph. So we're first going to graph the original function, I like to call it the parent, and then we're going to shift it left or right. Again, remember, if this confuses you, you can always just use your table function, plug it in, or get some ordered pairs. But I'm going to do the parent function. Let's take a look at the first one. Before we even start, I do notice that the number that has an exponent is 1/2. That makes this decay. A decay means that the right side of the graph is going to get really close to the asymptote. Alright, so domain, -infinity to infinity. I can figure out what the asymptote is by looking at what's been added on. Nothing's been added there, so my asymptote's at y equals 0. Go ahead and graph that. I also know that my a value is positive. Since a is positive, that means that the range is going to be 0 to infinity. My graph is going to be above the asymptote. Alright, so first I'm going to write the parent function. Well, kind of the parent function. I'm going to write y equals 3 times 1/2 to the x power. Alright, there, I fixed that. Okay, so from here I can find the y-intercept. So I'm going to plug in 0 for x. If I plug in 0 for x, 1/2 to the 0 power is 1. 1 times 3 is 3. So I've got a point at 0, 3, so I'm going to plot that. And then I want to get at least one more point. I mean, really, from there I know the right side's going to get close. I could probably do it, but I'm going to plug in 1. 1/2 to the first power is still 1/2. 1/2 times 3 is 1.5. So I'm going to plot that point. Alright, I'm not going to connect it because that's not really my graph. I want to graph my actual function, which is all of this. And the only thing that I haven't really focused on yet is that -6 that's up in the exponent. That -6 is going to make my graph shift to the right 6 spaces. So I'm going to take both those points that I already plotted and just move them to the right 6 spots. Alright, so you're going to see there's kind of some bluish, blackish dots on there now. I'm going to connect those, make my decay curve. Remember, decay means that the right side is going to get close to the asymptote. And I'm done. Let's take a look at the next one. Start with your b value, the number that has the exponent. It's a 4. It's bigger than 1, so this makes us a growth. Since it's a growth, the right side is going to go away from the asymptote. So it's growing away from it. Alright, we'll start with the domain. The domain, again, -infinity to infinity. Next I'm going to jump to my asymptote. My asymptote is always the number that's added outside, which is a 2. So my asymptote this time is y equals 2. So I'm going to graph that. Next I'm going to find the range. I can tell what that's going to be based on the a value. Since it's negative, so I know it's going to be below the asymptote. So it's going to go from -infinity up to 2. And again, same as my asymptote there. Alright, I'm going to start with a parent type function. I'm just going to not write the shifting that goes left or right or up and down. So I'm going to write y equals -2 times 4 to the x power. I'm going to use this to find a couple points. 0 will give me -2. 4 to the 0 power is 1. 1 times -2 is -2. And if I plug in 1, 4 to the first power is 4. 4 times -2 is -8. So I'm going to plot those points, but I'm not going to connect them. Remember, it's a growth, so the right side should be going away. I need to look to see what my shifting is going to do. So my shift, I'm looking at the exponent. It's an x plus 2, so that means it's going to go to the left 2. Each of those points is going to go left 2. And then the 2 that's added to the outside makes each point go up 2. So I'm going to take each of those points that I just found and go left 2 and up 2. So you'll see my 2 new points. Now you need to really know what the basic shape of this is. The right side needs to be going away. And then the other side is going to get really close to the asymptote. One side always is going to want to approach the asymptote. Alright, and we're done with that one. Let's look at a couple word problems. Growth and decay models. If you look, this is really 2 different formulas here. That's what that plus minus means. So I've got something called a growth factor and a decay factor. So that's where the plus minus comes into play. The growth factor is 1 plus r, because it's growing, and the decay is going to be 1 minus r. So there's really 2 formulas there. You'll never write plus or minus. Alright, it's going to be helpful to know what everything stands for. So the a sub t, this at the beginning, is the ending amount. Usually that's the answer. Our lowercase a is our initial amount. Or you might want to say your starting amount, if you like that better. It's what you're going to start with. And then r is the rate. And that rate will always be written as a decimal. So we'll need to convert the percentages to decimals. Alright, let's try one. Clara invests $5,000 into an account. So $5,000 is our starting amount. If you want to kind of go along, that's $5,000 is A. Into an account that pays 9% interest each year. So right there, since it's gaining, it's going to grow, this is going to be a growth, meaning we're going to use the 1 plus r in our formula. Write an exponential model representing the value for any year t. So a sub t is equal to the starting amount, which is 5,000, times, remember you got to pick either plus or minus. It's a growth, so we're going to do 1 plus r, but r is 9%. Remember, 9% we write as 9 over 100, so that's really 0.0, I can't write on 0.09, 900ths. So 1 plus 0.09, I'm going to get another 0 in there, to the t power. And then I would rewrite that a little bit fancier. I'm going to write it down here because I'm out of room. A sub t is equal to 5,000 times 1.09 to the t power. So this would be my exponential model. The next part is asking how much will her investment be worth after 5 years. So t here is 5. So all I'm going to do is plug in 5 where t was. And I've got to, at this point, get a calculator. So please maybe take a minute, hit pause, grab a calculator, plug it in, make sure that you can really get this to work. These ones aren't too bad. They're going to get a little uglier later on. But we're talking about money. So when you do money or work with money, you're always going to round 2 decimal places. So my answer that I got was $7,693.12. Again, remember 2 decimal places because we're dealing with money. Alright, let's try one more. A GPS system uses satellite information to locate a ground position. Abraham's surveying firm bought a GPS system for $12,500. Again, there is our starting amount, our lowercase a. The GPS depreciates, so this is a decay, at a fixed rate of 15% per year. So my rate this time is 0.15. Remember, we're going to switch that percent to a decimal. Write an exponential model representing the value for any year t. When you see that, it means leave the t there. Alright, a sub t is equal to our starting amount, which is 12,500, 1 minus r, r was 0.15, to the t power. Now, you can simplify inside those parentheses, and your model should look like this. A sub t is equal to 12,500. go ahead and plug in 1 minus 0.05 to get 0.85 to the t power. So here's my model. I can use this to find values. The next part of this problem is saying that I want to know how much the GPS system is going to be worth in 7 years. So essentially I just want to plug in 7 for t. From here you're just going to grab your calculator again and plug it in. When I plug it into the calculator I get 4007.21, and then some more decimal places. But on this problem it is saying to the nearest dollar. So remember, make sure you guys read directions. So to the nearest dollar, which would make this $4,007. So my final answer is $4,000. 4,007. Sorry. Alright, you're done. Go ahead and try the practice that's on Buzz, see how you do on this, and then I will see you in class tomorrow and answer any questions you guys have. Bye-bye.